going to invite Malte onto the stage. Malte is joining us. He's the co-founder and CTO at Deepset, where he builds Haystack and Deepset Cloud to enable developers all over the world to use LLMs effectively in their business applications. Before founding Deepset, he conducted NLP research at Carnegie Mellon University and worked for multiple startups as a data scientist. He's also crafting NLP applications for all kinds of businesses for more than 8 years and is convinced that development workflow and user orientation, which is kind of what Ron said just now, are the key criteria for successful NLP LLM projects. So Malte, the stage is yours. Thank you so much for joining us today. Malte, over to you.
Yeah, thanks for the kind intro, and welcome everyone to the session. I'm Malte, co-founder of Deepset, and basically for the last, I think, 5 years by now, we've seen at Deepset hundreds of use cases from our customers in our open source community. And in, I would say, almost every of these use cases, the LLM, or back in the early days, NLP pipeline, had to be tailored so that it really was fitting the use case. And this is the main theme for my talk today, like talking about this tailoring. And while tailoring was always part of the game, the methods for tailoring have changed quite significantly with the rise of LLMs. So today we will have, I would say, 2 key methods for tailoring LLM applications. There's retrieval-augmented generation, short RAG, and there's fine-tuning. And both got actually a lot of attention over the last 12 months. Many people talking about them, writing about them. And while it's amazing to see all the attention, it honestly also came with a lot of hype and noise. And sometimes this made it difficult, I would say, to separate the noise from the true value, and created a lot of confusion, certainly with our community customers. A lot of people reaching out, asking, when is fine-tuning really useful? What are the real limitations of RAG? What should I do? And in my talk today, I'd like to dive into those 2 methods and show you the pros and cons of each and in what situation they are actually useful. So hopefully when you work on your next LLM use case, you have a better understanding for which methods make sense to apply. I'll structure the talk in 4 parts. We start with a quick look at why we actually care about all of this. Why do we need to tailor an LLM application? And then we dive into both methods, so fine-tuning and RAG. For each, we look at how the tailoring works under the hood, when this is useful, and talk about one example use case from the industry. So let's get started with a why. When working with enterprise customers on use cases, there are, I would say, 4 needs that come up almost every time. Number 1, most of these high-value use cases we see out there include some type of internal company data. Often from a special domain. Could be aircraft maintenance documents, could be contracts, could be financial reports. The typical question that comes up then is, how can we tune the model to our data? How can we teach it about this internal knowledge that we have? How can we integrate this into our LLM application? Number 2, when our use case relies on this internal data, what data can we actually send to third parties? How independent are we on this third party? Especially with the events, I would say, lately around OpenAI, more and more customers are careful with depending heavily on one single provider and putting all the eggs in one basket. Number 3, if you overcome the first 2, the next big question is typically around quality assurance once things go in production. I think by now we all saw these models hallucinating, simply making up answers. And if this is an application being exposed to your customers that you're building, this could be extremely damaging to your brand. So how do you know that this is safe enough to deploy? How can you assess this quality? How can you monitor it even if it's live? And number 4, education is a big theme as well. I heard several CEOs, CTOs in the last months telling me that they work on 2 kind of key priorities. One is solving use cases with LLMs that really demonstrate clear business value. And second, upskilling their teams. Often this means really getting their hands on it, let them experience firsthand, not only buying off-the-shelf AI features, but really throw them into this experience of building. But all those four topics are, of course, important. Could probably talk hours about them. I'd like to focus today on just this one, the tailoring bit. And why does tailoring actually matter? Why can't we just take an off-the-shelf LLM and ask our questions directly? Let's look at two examples quickly. If you ask GPT for this question, you get a pretty diplomatic, vague answer like that. That Sam was CEO of the latest in April 2023, but yeah, you should better check yourself. We get such answers all the time. I think every one of us saw some of them. And usually they are either happening because the model doesn't have really the internal knowledge about the question, or the knowledge might be outdated and the model rather steps back and is careful. So this is one of the huge motivations for tailoring, changing the information that the model has access to. Could be very specific domain knowledge that the model has never really seen before, or it could be just really updating the knowledge with most recent events. Let's consider another example. Here we want the LLM to write a SQL query that returns the total revenue from our US East region for the last quarter. And GPT comes up here with an actual SQL query. Makes also quite some sense, I would say. However, probably in 99% of companies, this SQL query would not run at all, right? Simply because every database schema is different. You have different table names, different columns, different ways of actually defining regions. All of that is very custom, and the model is not aware about it. You also see here that the LLM is not only returning the plain SQL query, right? But it's also coming up with quite some sentences around it, explaining what it did and what you should know about it. If you now wanted to build an actual BI application or like self-service analytics application that, let's say, answers management questions for sales data, you would also need to change the behavior of the model here, right? So that it only returns valid plain SQL queries, nothing else, really that you can just execute it and run it against your database. And that must be rock solid. So all in all, you would need some tailoring here to make this also work for a real production use case. So what are our options for doing this tailoring? There are probably 4 big levers we can pull, and each of them can change our LLM application in a slightly different way. Some are rather helping with changing the knowledge of the model, and others, I would say, are rather changing the behavior of the model. For example, tone, or making sure that the output is always in a certain format. In this talk, we zoom into 2 of them, fine-tuning and RAG, and let's get started with fine-tuning. So let's look quickly what fine-tuning really is about. If we look at modern LLMs, there's a huge, costly training phase called pre-training. This involves really like terabytes of data, millions of GPU hours, millions of dollars, and really only makes sense if you are one of these big providers like OpenAI, Anthropic, or Meta, where it's key of your business model. This is the phase where the model really picks up their knowledge and their initial behavior. And yeah, these are the generic LLMs that we all know: GPT-4, Claude, Llama 2, and so on. When we talk about fine-tuning, we usually mean the second training phase here, where you can take any generic LLM and continue some training on a smaller, more specific data set. Usually, this also involves then a different training objective and a different training method. So it's really a very separate phase. This fine-tuning of LLMs actually became accessible, I would say, only really within the last year. We saw many public offerings from like LLM providers where you can get started within minutes using the public APIs. There are also very good open source frameworks out there, like PEFT from Hugging Face, that simplify this whole procedure dramatically. And I would say the promise sounds very appealing, right? So you can basically get your own tailored GPT for a few $100s in a few hours. Awesome, right? Let's just get one fine-tuned GPT for everything and forget about prompt engineering and the rest. This, I would say, was quite a hype in summer. It, I would say, peaked probably around August, September this year, Reddit, Hacker News were full of threads about fine-tuning and people discussing it. And it seemed that, I would say, a fine-tuning of these huge LLMs became not only a lot simpler around summer, but also economically feasible within a quite short time frame this year. So to understand all of this a bit better, let's zoom into fine-tuning and the methods behind it. I'd say there are today 4 major methods that people use for fine-tuning, and all of them are super different in their approach and exact algorithm. But one thing that all of they have in common, they never continue training all model parameters. This would be insane with these large language models, really not feasible. All of those 4 methods only adjust a tiny, tiny fraction of the model parameters, and the rest just stays untouched, stays the same. Those parameters that we actually adjust during fine-tuning differ now in each of these 4 methods. Some of these methods look at the end of the model, some of the starting layers of the model, some look at certain parameters in between. That's basically how they differ. The most popular method right now, I would say, is the one on the bottom right corner. It's called LoRA, and let's double click on that. LoRA stands for low rank adaptation of large language models. And yeah, again, goal here is really to just a tiny, tiny fraction of parameters from the LLM. In contrast to the other methods, this approach is not about picking a certain layer in the model. Instead, we apply a common trick from matrix calculation. You can basically heuristically decompose one huge matrix into the product of 2 way, way smaller matrices. So let's say W0 here are our parameters in a pre-trained LLM. So we like these millions and billions of parameters. If we really want to adjust all parameters of the model during fine-tuning, this would be W delta here in the equation. The matrix is the same size as the original one, pretty much infeasible to do for fine-tuning. What we can now do instead is that we replace W delta with a product of A and B. And A and B are both now very, very small matrices. In practice, we are speaking here about less than 1% of parameters in comparison to W delta. And the cool thing is that this only reduces our final model performance by a very, very low margin. So it's really a nice trick, few parameters, but almost the same performance in the final state. This reduction in parameters makes a huge, huge difference for feasibility of training and inference. Training becomes faster, cheaper, more accessible, basically. And I would say probably even more important, inference is now also way, way cheaper. And as a model provider, I can now run basically one single model with W0, like our huge metrics. And now for every customer that with a fine-tuned model, I simply load A and B on top, like on the fly, in memory. This is only a few megabytes, and I can really load and serve hundreds of custom models from a single machine now. So I think this is kind of explaining with the background why last summer everyone started talking about it, why companies pushed out commercial offerings for fine-tuning, and kind of became simpler, faster, and economically feasible. But when is it now really useful? I'll say there are a lot of simple, fast, and cheap things out there. Still, I only care about very few of them, only if they are useful for me. So let's look at this a bit. Fine-tuning is mainly useful for 2 things. It can improve the performance of very specific tasks, and it can help with speed and costs. So let's look again at both points here. Fine-tuning can improve performance in very specific situations. It's not a generic Swiss knife that you take out if you're just unhappy with your performance. It really only works in very specific cases. The best way to understand these specific cases is this intuition up here that was shared by John Allard and Colin Jarvis at the OpenAI Dev Day a few weeks ago. And they said, if prompt engineering doesn't increase performance, fine-tuning most likely won't help either. And I think this is like super nice rule of thumb. If you tried already a lot of prompt engineering and still the model responses don't really improve in the direction you want, fine-tuning will be just a waste of time. From my experience, fine-tuning is really great when you want to change the behavior of the model. You can emphasize existing knowledge in the model. For example, let's say the model already knows a bit about Python, but you want to make sure that your coding assistant really always generates Python code and maybe in a certain way. You can adjust the tone of the model. For example, if it should generate blog articles and follow the tone of a certain author, certainly doable. You can adjust the output format. So if it's, say you always want to respond with a certain JSON format, yes, fine-tuning is nice. All of those cases work, I would say, really well with fine-tuning. And typically, those can also be improved via prompt engineering. So those two go really hand in hand. Of course, prompt engineering is limited by the number of input tokens that a model can really take. And this is now a big difference. This is not the case for fine-tuning. There you can easily provide thousands of examples and continue. All right, so improving performance was one of the cases where fine-tuning can be useful. The other is, where it really makes sense, is efficiency. So fine-tuning can help to improve speed and costs in two basic ways. First, while you can, in theory, increase the length of your prompt these days to 100 or with latest Anthropic model to 200K tokens, this gets very expensive and very, very slow. Single cost, I think it costs around $2 then, but takes also like a long time to answer, more than 15, 20 seconds. And with fine-tuning, you can basically bake the prompt into your model. So at runtime, you then don't need any prompt, or maybe only a very, very short one. So this reduces the costs and latency per call. The second way to reduce costs, and some people did that, is applying fine-tuning for so-called distillation. They fine-tune a cheaper model, like let's say GPT 3.5, with data that is coming from a larger, more expensive model, GPT-4, for example. And the cheaper model now then mimics the behavior of the larger one, and for many use cases, that's actually quite helpful and more efficient. Of course, there are also cases where fine-tuning is not useful. And this gets mixed up a lot on social media, so I'd like to emphasize those cases as well. Most importantly, I really haven't seen any case in the industry where LLM learned completely new information via fine-tuning. From all conversations I had in the last months, fine-tuning never really helped for adding completely new knowledge. You can emphasize existing knowledge in the model and make it really focus on it. That's pretty much it. Fine-tuning is also a bad choice for keeping knowledge up to date. So if you have, for example, internal wiki that changes every hour, it's really impractical to trigger a fine-tuning job then every hour. More generally, it's also not really the right choice for fast iterations. It takes quite some time to create a data set, running the job, testing the model. So this should really be never the first thing you do on a new project. Always start with selecting the LLM and then continue with prompt engineering. Only if you run then into a dead end at some point, then you should probably consider if fine-tuning is the right thing for you. Last but not least, reducing costs is on our list here too. As we learned on the previous slide, there's actually a good chance that we can lower our costs with the help of short prompts. However, there's also here no free lunch. Most model providers charge something around 3 times the costs for every token that we send to a fine-tuned model. So this means your prompt really needs to shrink to at least 1/3 of the original prompt you had. Otherwise, actually becomes more expensive. So be careful and do the math yourself here. All right, so we talked about the method and when it's useful. Let's now illustrate this with one actual use case from the industry where fine-tuning was successfully applied. For this case study from Canva, all credits go to Alart and Jarvis, who shared this one at OpenAI Dev Day. And honestly, I think this is one of the very, very few case studies out there that go beyond theoretical benchmarks or demos, but show instead some real production scenario in a company. So what did the team at Canva do? They wanted to generate a design mockup from a short freestyle text description that a user gave. So they took these text descriptions, fed them to an LLM, and the LLM translated that now to a more professional, structured description of the desired design. Based on that description, they were then able to find or create the appropriate mockup, showed that to an expert user, and got some rating for it. And this expert human rating was used as an evaluation metric for their LLM application. Off-the-shelf performance was not really great here in that use case, and even with prompt engineering, they only achieved a quite low score here. They tried then different LLMs, switched from GPT 3.5 to GPT 4, improved the score slightly, but still didn't really move the needle. And as a third step, they then fine-tuned actually a GPT 3.5 model, and turns out that this worked now way better than anything before, and now was actually really good enough to move forward with their implementation. So I think this is like a really nice use case where tailoring is not about changing the knowledge, but it's about changing the output format and making the wording in there more consistent to the design language that was required here by Canva. Let's now look at one method that is very popular for changing the knowledge of an LLM, RAG. Let's start again with a look at the method and how it works. If we use a regular plain LLM, we basically take a question from a user, ingest this question to our prompt, and feed that to the LLM, get our answer back. Now, simple. With RAG, the pipeline doesn't change too much. The only difference now is that we add a so-called retriever model in our pipeline that can add more useful context into our prompt. We can basically connect the retriever to any relevant data source that the LLM should be aware about. The retriever then searches through these data sources at runtime, identifies the few most relevant pieces of information, and inserts them into the prompt, here in the graphic in green. In practice, this data source is very often a set of text or PDF files that you index into a vector database. But this can be literally any data source that you have. It could be a SQL database, the web, an API of a tool you use, any data source that you can query at runtime to find useful information. In our open source community around Haystack, we see actually people getting really creative here, adding very different type of data sources, and then also combining them in interesting ways. So you can build pretty fancy pipelines here that decide, based on the question, which data source to use or how to combine multiple of them to really create the most meaningful prompt for the LLM. Okay, so let's look again when RAG is useful. By connecting these different data sources, it's actually super easy to provide new and updated knowledge to the LLM. So if you update your data source, your LLM application has basically immediate access to this new data. There's not really a delay. RAG is also a great way to reduce hallucinations. So if you can prompt the model in a way that it really forces it to stick to the information that is present in those retrieved documents, which is very helpful. And there's another very nice side effect to it. The answers now become explainable, because for every sentence in your answer, you can now basically trace back from which passage in a document or like in a data source they were coming from. You can use that for debugging as a developer, but of course you can also make this a nice feature in your UI for end users. Of course, RAG is also not a silver bullet for every situation. It's not very useful if you want to adjust the tone or style of language in your generated text. This is better done with prompt engineering or fine-tuning. It also doesn't help with controlling the output format. So if you struggle with generating a valid JSON in a certain format, RAG won't help. It's also not really useful when you want to restrict the model to a very specific task where the performance of the generic LLM is not good enough. So for example, imagine you want to classify internal wiki articles into 20 custom categories of a company. A generic LLM will very likely pick up wrong names for these categories from time to time. It won't stick to just your 20 custom categories. And RAG won't help here. Fine-tuning or prompt engineer, again, the right tools to go for. Okay, so let's now wrap this up with one exemplary success story for RAG from one of our customers at Deepset. So this is a major news publisher with millions of visitors on their website every day. And they basically wanted to provide their users with another way of interacting with all that information available on their website. And in this information assistant here, users can ask a question and the RAG pipeline then generates a comprehensive answer. It also links the original articles then as sources for each part of the answer. So this allows users to get a quick overview, but also then dive into the topic in more detail and read up about it if they're interested. How do they solve this now from a technical side? They plug basically their whole huge archive of articles into a RAG pipeline, and then optimize this pipeline heavily for their use case. It started basically with evaluating different LLMs, nothing fancy here. GPT 3.5 was the best option that they found. The team then applied a lot of prompt engineering to add those citations, adjust the tone, reduce hallucinations, and also making the model aware of the current date, which is for news always quite relevant. And then after plugging this now into a basic RAG pipeline, they got a first baseline of 65% recall, which is our evaluation metric here for retrieval. Most of their actual optimization work then went into tuning this RAG system further. With pretty great success, they ended up with a 99% recall. Let me share now some here of the techniques, as they might help you as well in your project if you go the RAG route. It's always good to compare a few different retrieval models. So from our experience, the open source E5 model series from Microsoft is a pretty good model family to try out there. And in most cases, you really don't need to benefit from using LLM as a retriever. These smaller open source models usually better and way cheaper. Combining vector search with classic good old keyword search, BM25, is also super helpful, can definitely recommend it. And another option that gets less attention out there, but often proved to be a big lever in our customer use cases, is leveraging the metadata of documents to improve performance. This could either mean simple filtering of your search, but can also mean really embedding some fields of your metadata and using directly for vector search. Another element to try are rankers. You can put them into your RAG pipeline, and rankers have proved to be quite useful already in traditional information retrieval systems, and the same basically holds for RAG pipelines. In RAG pipelines, in most cases, they can particularly help you to improve costs and speed. They often allow you to keep the same performance with fewer documents, so really reducing the number of documents and therefore shrinking the prompts. One last thing that the team tried here in terms of performance optimization was fine-tuning of the retriever. And while this actually helped in several customer cases in the past, didn't improve performance here this time. This always really depends on your use case and data. And in this case, I would speculate the data for news publishers probably already quite close to the public data that many of those retrieval models were already trained on. After the general performance was good enough, the team added some more guardrails to the pipeline to monitor hallucinations and block harmful prompts of users. So you see, there's quite a few knobs you can tune in a RAG pipeline, and it usually really pays off in performance. These points might look now like a lot of work, but if you have the right tooling and a clear evaluation metric in place, it actually super fast iterations, and you can drive your optimal pipeline really in a few hours or days. All right, so let's wrap up what we learned today. We looked at two methods. While RAG rather impacts the knowledge of the model, fine-tuning impacts the behavior and style of it. RAG can help with explainability and reduce hallucinations. Fine-tuning can be interesting for speed and costs. Last but not least, with RAG, your iteration speed, usually pretty fast, can easily experiment, if you have an evaluation metric in place. I'd like to end my talk by really zooming out here again a bit and emphasize that those debates now, which technique is better, are actually not useful at all. These two methods are really solving different problems. I hope that came across. And you should focus your energy on figuring out which problem do you actually want to solve in your use case. What is the bottleneck? What do you want to tailor? And it's like with these potions in the image here. There are green and blue ones. You should have both in your toolkit. Once you know which effect they have, you can easily select and use them appropriately to solve your problem. You can even mix them if your problem really requires that. That's definitely doable. Finally, I would really encourage everyone here to kind of move back from alchemy to solid engineering practices. We've seen quite some POCs this year that didn't go anywhere, but I also have seen quite many becoming successful and moving to production. The key difference from those two cohorts is very simple, not different to classic software engineering. You need to be able to iterate fast, and you must be clear if each iteration is actually moving you closer to the target or not. If you want to start building applications yourself, check out our open source framework, Haystack, and our enterprise platform, Deepset Cloud. They really allow you to move faster and build your custom LLM applications. You can also ping me on LinkedIn or X if any further questions come up, or if you want to get the slides. Thank you.